Hi Year 7s, I've decided that the easiest way to help you with your revision is for me to explain my answers to the revision sheet in this video. I went through the first couple in class, but I'll just go through them very quickly again. For the first question, part A, inertia is greater the greater the mass of the object, therefore the elephant has greater inertia. The reason a person inside a bus that's turning leans to the right side, not the left, when it leans left, is that their inertia causes them to want to stay where they are. So when the bus moves to the left, they seem to move to the right when they're actually kind of staying still. Gravity is a non-contact force because you don't have to touch the earth to feel it, and weight is measured in kilograms. When you jump on the scales, it says 43 kilograms or whatever you are, even though the weight force would be measured in newtons. So that's a bit of a tricky question. Right, examples of a pushing force are just things that push. It's really not that complicated. The next question is about friction. And remember that the more friction something has, the more bumpy it will be. So anything that is very smooth, or anything that has a layer of liquid on it which smooths out the bumps, will have very little friction. Question 6, we're just talking about contact and non-contact forces again. Now you'll note that I have highlighted or done circles around the bits of the question that tell me how to answer it, the key parts of the question, explaining the difference. If all you do here is write down some examples of contact and non-contact forces, you won't get all the points for the question. So the first thing I've done is explain what's the difference between a contact and a non-contact force. The second bit is explaining, giving some examples of contact and non-contact forces. And rather than writing lots of sentences, I've just done arrows between them. So the contact force is hitting or friction. They're just some examples. And the non-contact force is gravity or magnetism. We haven't really talked about magnetism, but it is a non-contact force because magnets don't need to be touching each other or your fridge for you to feel the force. This next question about inertia was a bit tricky. I went through it in class. I'm not going to waste time by going through it again now, but believe me, you're not going to get a question that asks you about inertia in this way in the test. As long as you know that inertia is the property of something that keeps it moving once it starts moving, like a boulder rolling down a hill, it's hard to stop because it has a lot of inertia. But also, if that boulder was on a flat plane, it would be hard for you to get it moving, again, because it has a lot of inertia. That's what you need to understand about inertia. Right, this next question was a little bit tricky just because some of those extra words had been left in when it was pasted from the textbook. But Bernoulli effect refers to the fact that when air flows over and around something, if more of the air gets directed underneath it, there'll be more air pressure underneath, and therefore it will be lifted up by the force of that air being forced underneath it. So it's called the Bernoulli effect. Alright, I don't know if you did that. Let's just delete it. But this next question is about forces. And, okay, I can't delete it. Ignore that. Right, forces can work in different directions, as you know. And if you've got 10 newtons going up and 10 newtons going down, they're balanced. This is just like when you're standing on the ground. You're not sinking through the floor and you're not floating up in the air, because the force pushing you down or pulling you down is the same as the force pushing you up. So this one, A, it's not going to move anywhere. So I've said NAA, or not at all, for how that one's moving. Now, B is also pretty simple. You've got more force going left than you have going right. Therefore, it's going to go left. C, you've got the same forces going left and right. So it's not going to move left or right. But you've got more force going down than up. So it's definitely going to go down. And D, the force is all to the right. So that's the way it's going to go. Right, this next question was asking you to look at the braking distance of old and new tyres, and it's asking you to look at a graph. Now, this first part of it is really just about how well you can understand the graph. So what we need to do is have a look at this graph. They're asking you which has the longest braking distance. So this scale is about braking distance. It goes up to 50, and obviously this big red bar here is the only one with a very long braking distance. The rest of them are much, much smaller. So let's have a look at the properties of this one. It says on there that it's old tyres, so that's the first thing you need to note. If you move to the left here, it's the smooth asphalt. So smooth asphalt and old tyres. You move left here again and it's wet. So all the stuff up here is for dry roads, all the stuff down here is for wet roads. So obviously wet roads with smooth asphalt and old tyres have a longer braking distance, takes you longer to stop. So remembering that, we'll move back up to the questions. And part A says, which combination of factors produce the longest braking distance? As we just said, old tyres, smooth asphalt and wet. Now you need to put in all three to get full marks for that question. The next is explain why you've chosen these factors. And that's because what the graph shows. It would have been better if the graph was there and you could just point those things out. That's not the kind of question you'll see on a test. Part C, describe the weather conditions under which tyre performance varies the most. Okay, so what we're talking about is the weather, not the road surface. And we're talking about it varying the most. So the biggest difference between the different things. So looking at the graph again, all of these, see there's not actually much difference between new tyres and old tyres. Even here, there's more difference, but still not that much. Here, you've got huge difference. But we're not asking about the road surface. We're asking about whether the difference is greater in the wet or in the dry. So it's quite obvious that the difference is much, much bigger in the wet. Right, wet conditions, much bigger differences. Part D, state whether new or old tyres vary the most in performance. So we're not talking about which one's safer, old or new tyres. We're asking about which one has the biggest difference between, which one has the biggest difference between the smallest graph and the biggest graph, or bar. Now the new tyres, it really doesn't change very much, so it's obviously not new. Old tyres, you've got old tyres on smooth concrete in the dry, quite small, and up here on smooth asphalt in the wet, it's huge. So that's definitely the biggest difference. Okay, next question, editing error, ignore that top bit. Part E, explain why or how old tyres are not as effective. So this has nothing to do with the graph. This is about your understanding of friction and how tyres work. Now, tyres have bumps on them and they also have grooves in them. And old tyres get worn down so that the grooves and the bumps are not as obvious and the whole tyre surface ends up being quite smooth. Now, the grooves and the bumps have different ways of helping you. The bumps increase friction the grooves channel water out of the way so that you're hitting the road surface instead of sliding on that layer of dangerous slippery water, which can act as a lubricant. So as long as you say those two things, you'll get full marks for that question. Again, that's a pretty tough question, but you will get tough questions on the test. I'm going to pause now and we'll start the next question in the next video.